unless you're new here, you've probably seen my face here and my biped robot a bunch of times. And I have been pressuring myself to show something every month. I do a lot of work on it, but as anyone else that builds robots knows, that the day before is not the time to finish up and then to give you a demo. So I decided not to spend the last night doing the demo, and just to show you the progress that I've made, except the mouse is not working. Oh, I guess you have to plug in a USB. It helps too, right? So the board here is this board is a TX2, which is one of NVIDIA's latest boards, and its job will be to analyze the sensor data and find the best way for the biped robot to perform moves like squat and stand on one foot and translate forward and basically learn how to move. The data that we have so far, and this is a program that I wrote using Glut and Glue. And so these are open source graphics programs in C++, and I am not a super C++ programmer, I'm a C programmer. There is a difference. But this was really relatively easy to put together. And so rather than call the robot's legs right and left, we have red and blue, because you never know whether it's walking towards you or away from you, and it's hard to describe. So the last time, 2 months ago, it was only one of these. This was just the red leg, and there are 4 load sensors in each of the 4 corners of the foot, and this blob moves around depending on the center of mass, and this is the total mass. And this is the blue leg. These are the servo positions, and this is the control panel, so I can test and enable things and send it into different positions right now. The improvement has been in the fact that now this program has 2 legs, which is going to be a lot easier. And so, and last month I brought the robot in, showing the mechanics of the 2 legs. And I had a problem with the Pololu board where I had to take it apart to put capacitors on the motor. And so I didn't have time to reassemble things. And so this is what it is. And it's going to just keep getting better. And the nice thing about this program that I like over robot operating system and other things is that I can completely control everything. And when you go to start it, it just starts, it just runs. It doesn't take 40 seconds to boot up. It's very lightweight. And processor, the fan on this guy, I've yet to get it to turn on. So if you're the NVIDIA guys will tell you, when you start processing video, this thing is going to get hot. But right now, just to run this kind of stuff, I'm going to have like a bagger to collect data, and we'll open up a video port for the cameras and show you the IMU data. That'll all be next month, hopefully. And working on that also for Baker. That's pretty much it.
This is a standalone, tripod mounted LiDAR scanner using the scan sweep sensor, and it's all 3D printed. You need of course, the sweep sensor, but everything else is pretty standardized. It's a Raspberry Pi and some 3D printed parts and USB cables, and other than that, that's pretty much about it. And it has its own little, I'm sorry, what?
How far out does that detect?
Actually, I'm going to show you here in a second.
Pretty far.
Pretty far. The interesting thing about the sweep over some of the other LiDARs is that, here, let me restart this. They actually chose to go for long range rather than high resolution. So unlike a Hukoyu or a Velodyne or something like that, you're not going to get, or I guess probably more like the Hukoyu, you're not going to get like a super high res of everybody's head in here or something like that. What you're going to get instead is distance. It's mostly they were originally intending it for like obstacle avoidance and things like that. So this is, oh actually I didn't put this up, did I? Let me go look at that. Ah, there we go.
Congratulations.
There we go. This is video. Now, turn it on here. So, it's all pretty cool because it uses USB power from like a big, charge your iPhone 50 times kind of battery bank, and there's a Wi-Fi thing on it, and there's a level, so you can make sure that it's level. It has B&O 55 IMU on it, so that you can like tell if it's level, or you could use it to sense like if you wanted to take multiple scans of a space, you can like move it and tell how far you moved it. I'm adding a GPS. It's all open source. I'm adding a GPS to it so that you could match the scans up. I'm trying to find my displays here. This is not things for some reason. Ah, there we go. Things usually work best. Things usually work best when plugged in. Yay. So can we see that?
Not yet.
Not yet. Okay.
Pick local
Local
input there.
station.
Mirror is a separate display.
On the right side of the podium.
On the
you
dashboard,
have
right?
local input selected.
Oh, local present input. Yay, okay, there we go. All right. So, just make this big here. So this is a scan of the room that of this room here that I took right before the meeting. If we rotate it, this is using a piece of software called Cloud Compare that lets you process point clouds. So as you can see, not a whole lot of detail, but the cloud itself is actually, it covers the whole room. So this is something I'm just kind of playing with, and it was a neat project to put together. Gave my printer a good workout, and other than that, I had pretty much all the parts on hand, which was sort of the point of this, is that, work through the part stash. I had the sweep sensor that we got from when I was doing Service Robot Labs. They gave us a sweep sensor. It had been sitting in a box, a bunch of Raspberry Pis laying around, a bunch of filament, USB cables, and a stepper motor, and that's pretty much about it. It has its uses. I don't think I would want to use it for like super high-res mapping, but you can see like it's picking up the ceiling, it's picking up the lights in the ceiling. It's pretty cool for what it is. Anyways, come talk to me afterwards. Thanks for your time.
Okay, we're going to attempt to get a video on this. Bill, can you? Okay, I'm going to make it go out.
That's right.
I don't think you guys can see that very well. Anyway, so this is Magni from Brew Robotics, and it's following a water bottle using the power of the NVIDIA Jetson Nano. So there's a Raspberry Pi camera on there, and the Pi camera is taking images and it's giving them to the Nano, and the Nano is running a deep neural net at around 8 to 9 hertz, and that's detecting, looking for any bottles in the image. So that's just one of the pre-trained nets that's available. You can make it do whatever you want if you have the computational resources to do your own training. So yeah, so right now this is following the bottle. I'm going to drive it a little bit so that I can actually get behind it and you guys can see it a little better. What if I move it over there, Mark?
It's got drop sensors, right?
In front of the podium?
Yeah, in front of the podium.
That's about all we got.
Alright. Anyway, so let's see. This is going to try and follow this bottle. To show that there's no funny business with this bottle, I grabbed one right out of Google's fridge over here. And it's going to be able to follow this guy too. So yeah, this is using their pre-trained net, like I said. So NVIDIA has this thing on their website called 2 days to the demo. And this Magni doesn't add anything to that. So if you want to do 2 days to a demo with Magni and the Jetson, you can do that too. So this is a very simple following script I wrote. It's like 20 lines of Python. It's not the most optimal thing. I could probably stand to not crawl super close to me and also be able to go backward.
Can you walk it over that way?
Yeah.
Because then the camera will see.
Yeah, the problem with the following robot is that wherever you stand, the robot's going to try and follow you. So you can't keep it in one spot. So you can also make it try and follow people. The only reason I'm not having it follow people is the neural net on the Jetson is too good, and it's able to detect partial people. And there's a lot of you out here, so even if it glances one of your legs, it might latch onto that instead of me. So I went with the bottles.
Follow me home.
Yes, it might follow you home, and then we're going to have to chase you down and get our robot back. So yeah, this is a pretty basic thing. Well, pretty cool thing that was really easy to do thanks to the power of the Jetson Nano.
I guess you already did my work.
Okay, we're going to take a very short break. This will be 5 minutes. If you don't recall where the bathrooms were, follow the crowd probably, but I think it's down the hall. We're only allowed to just go to the bathrooms and back and not hang around in the aisles or stare in people's offices because Google has been kind enough to let us use the